Today we're looking at 3.1 factoring polynomial expressions. This should be a review from grade 10 math because you did do it last year, so we're just going to take it one step further. So quick review: when you have a polynomial, you have a monomial. It deals with just one variable with an exponent, with a coefficient. Binomials, two numbers with the operation between. Trinomials, three numbers with the two operations, and the difference of the square, where you have your x squared minus 9, so that's the key right there, minus 9, which we'll do at the end. So solution to factoring the trinomial like this: two sets of brackets, put the x up, and then look for the factors of 15, which are 1 times 15, 3 times 5. Out of those, which will give you 14, it'll be negative 15 plus 1, and then substitute them in, and then you're good to go. So we will try one and take a look at it. So we have d squared minus 4d minus 21. First step was to put two sets of brackets down. Second step, split the d up. Because it's got two, I'm going to put one here, one there. Now I'm going to look at the 21. I'm going to look at factors of 21, which are 1 times 21, 3 times 7. That's it. Out of those two groups of numbers, what will give me negative 4? It'll be this. It'll be negative 7 plus 3. And there's my answer. So once again, we look at B. I can put down two sets of brackets. A can be split up to two parts. Factors of 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Out of those, which one will give me 2? 4 and a 6. How do they do it? It'll be negative 6 plus 4. And there's my answer. When we look at part C, we see that we have a coefficient in front of the variable with the x with the square, so we gotta do something different. So you see if you can factor things out. So I can take a 2 out of there, and I'm left with x squared plus 3x minus 28, which is the same as up here. So two sets of brackets, put the x up, less the factor of the 28, which will give you 3, and it ends up being 7 minus 4 equals 3. And from that, I just substitute that into the equation, and I'm good to go. So for this one, take a look at it. I see 2 can be taken out of everyone, so I take 2 out of there. I'm left with x squared minus x minus 6. It is a trinomial. I can split the x up, so I'm going to put down 2 again, two sets of brackets. I then look at the factors of 6. 1 times 6, 2 times 3. Out of those, what will give me negative 1? It'll be this one, so it'll be negative 3 plus 2. And there's my answer. On B, same thing. Take 2 out. I'm left with x squared minus 6x plus 9. X squared can be split up into 2 equal parts. So it goes x here, x there. 9, 1 times 9, and 3 times 3. Out of those, it'll give me negative 6. It'll be negative 3 minus 3, and that gives me negative 6. And then to check it, I take the 2 down. X times x is x squared. X times 3x is minus 3x. Minus 3x plus 9. Group like terms. So I get 2 times x squared minus 6x plus 9. Bring the 2 back in. We get 2x squared minus 12x plus 18. This equation is the same, so it's a quick check to see how it works. Part C, factoring trinomials, rational coefficients. Rational coefficients means it's a fraction. So we got 17 over 3. First step is you want to get rid of the denominator, which is a 3. And to do that, you multiply everything by 3. And what you do to one side, you must do the other side as well. So it comes out, the 3's cancel out here. That 3 comes in, and you get 3x squared. That 3 comes in, you get 6. And from there, you can then follow the steps. There's factors of 18. That'll equal negative 17, which are negative 18 plus 1. Substitute them in. Then you have to group them. And after you group them, you look for your factor it again, and you end up getting your factor number. So here we go. I got 3a squared minus 29 over 2x plus 14. First step is to get rid of that 2 because it's a denominator. So I'm going to multiply everything by 2. So multiply by 2, 2, and 2. No cancellation there, so 2 times 3 is 6x squared. These cancel out, so I'm left with minus 29x. And that's no cancel out here, so I'm left with 28. From there, I can't split this up in evenly. I can't have 3x and 3x because 3x times 3x would be 29, and that won't work. So I then take this number, bring it over there, and multiply it. And I get 168. List the factors of 168. So 1 times 168, 2 times 84, 3 times 56, 4 times 42, 6 times 28. 7 times 24, 8 times 21, and 12 times 14. Out of those, I can see 8 and 21 will equal 29. So I rewrite that. Now, the key thing here is we're going to see 8 is associated to 8, and the 28 and 21 can be associated either one as 2. So I'm going to put the 8 with the 6x. So I get 6x squared minus 8x minus 21x plus 28. These two in here equal that. So that's why you substitute. I then group them and make sure you take everything inside, even the sign. I then factor this. So I have 6x minus 8x. What's common for that? They both have a 2 in them and they both have an x. So I'm left with 3x minus 4. This is what I'm going to try to look on this side. So how can I make that out? If I take out negative 7, I'm left with 3x minus 4. I then group this, 2x minus 7, so the numbers on the outside brackets join together. These are the same numbers, so I'm just going to rewrite them once. And there's my answer. For this one, they give me a hint. I got to multiply by 10, so I'm going to go 10x plus 14x minus 12. So that's these multiplied to give me that. Can't split the 10x squared up evenly, so I then take 10 times 12 is 120. Factors of 120 are 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 8 times 15, and 10 times 12. I'm looking for 14, and these will equal 14. So rewrite it. 10x squared plus 20x minus 6x minus 12. So 20 minus 6 gives me 14. Group them. Pull out what's common here. They both have a 10 and an x. I'm left with x plus 2. That's what I'm looking for over here. So if I take out negative 6, I'm left with x plus 2. Rewrite it down once. 10x minus 6. And these are the same. X plus 2. And there's your answer. So a little more work. A little more challenging, but doable. Part D, factoring a trinomial by looking for a pattern. So if I look at this one here, these two are the same. So by looking at those, I can see that I can replace them with a variable. So a squared plus 6x minus 16. Then go ahead and find the factors of 16. 1 times 16 times 8, 4 times 4. Out of that, what will equal 6a? It'll be 6, the 2 and the 6. I then put it back in, I come with that, and then I put the equation back in. Now substitute a, this should be plus, and they come in there, and there's my answer. So, in other words, it looks like this. X minus 6, x minus 5. I'm going to replace that with an x. So I got x squared plus 5x minus 24. I can factor the x. X goes here, there. 24 is 1 times 24, 2 times 12, 3 times 8, 4 times 6. Out of those, what will equal 5? The 3 and the 8. So how do I get that? It'd be plus 8 minus 3. I then replace x minus 6 with an x, so I bring it back in. X minus 6 plus 8. And over here, x minus 6 minus 3. Look for common terms together, so there's no x's, but I have x plus 2. And over here, I end up with x minus 9. Done. Same with this equation over here. I have 6x squared minus 21x plus 15. I see I can take a 3 out of that, so I'm left with 2x squared minus 7x plus 5. I can't take anything, I can't split this up evenly, so then I go 2 times 5 is 10. Numbers give me 10 are 1 times 10 and 2 times 7, or 2 times 5. Out of those, will give me 7, the 2 and the 5, so I replace it. 2x squared minus 2x minus 5x plus 5. Group them. Look for common terms, so I got a 2x here, which is equal to x minus 1. So I'm going to take a negative 5 out here, and I get x minus 1. Put your terms together. So I'm going to have 2x minus 5 times x minus 1. You then replace the 3x minus 4 back in there. So 2 times 3x minus 4 minus 5. And this will be 3x minus 4 minus 1. So I then get 3 on the outside. I get 6x minus 8 minus 5. Here I get 3x minus 5. Got to run out here, run out of room. Could combine the like terms, so I get 3 on the outside, 6x minus 13, and 3x minus 5. And there's my answer. So once again, a little more challenging, but doable. Just take your time. You get in trouble, and stop and ask for help. Factoring using the difference of a square. So difference of a square, you gotta look for this symbol there. A squared minus b squared, 9a squared minus 64b squared, 27a squared minus 12b squared, and then you take things out there. But take a look. A squared minus b squared is equal to a minus b, a plus b. 9a squared minus 64b squared is equal to 3a minus 8b, 3a plus 8b. So same thing. So here, I got that. I can split this two sets of brackets. 6x here, 6x there, 7y, 7y, 1's a plus sign, 1's a negative. Done. This question here I can't do, but I take a 2 out there. I'm left with 4m squared minus n squared. I can then factor the difference in the square of the 4, so I get 2m minus 1n times 2n m plus 1n, and there's the answer of that one. This one a little challenging, a little different. So I can go 9a squared minus 4 times 9a squared plus 4. If I take a look, this is also a difference of a square, so I can go 3a minus 2 and 3a plus 2 times 9a squared plus 4. So same answer as down below. So a little easier, but you got to be careful. This is what you want to look for. All right. And the last one we're going to look at deals with factoring the new difference of a square. So once again, we take a look at it. I see there are some different terms in there, but it can be doable because of the difference of a square. So I got x squared minus y squared, which is equal to x minus y times x plus y. Because I substitute the x in for 2x, and I bring it back in. 2x minus 1 minus y plus 4 times 2x minus 1. Now I'm not putting a set of brackets on here because this is a plus, so I'll just bring it in. Y plus 4. This is brought in because that has to go to everything there, which we'll do later. So that 2x minus 1 minus y minus 4. And here I get 2x minus 1 plus 4, y plus 4. So I just rewrote that one. Look for common terms out. There's only 2x there. Negative 1, 5 minus 5. Here I'm going to go 2x plus y. Try to go variable first. And this gets plus 3. And there's your answer. Same thing here. Replace the x plus 2 and 2y minus 3 with a variable. So I get 32x squared minus 18y squared. This will be fixed on your worksheet. It'll be a small 2. So I can't, these are not perfect squares, but if I take a 2 out of there, then I get 16x squared minus 9y squared, and these are now perfect squares. So I go 2, 4x minus 9y times 4x plus 9y. Once I do that, I bring back what I replaced them with. So x will be replaced by x plus 2, so it'll be 2, 4 times x plus 2 minus 9 times 2y minus 3. This one will be 4 times x plus 2, and this will be plus 9 times 2y minus 3. Bring the number in. So I got 2 on the outside. Here I get 4x plus 8 minus 18y oh, that should be a 3, sorry. Minus 6y plus 9. Here this will be 4x plus 8 plus 6y minus 9. Look for your like terms. Nothing there, so 4x minus 6y plus 17. And this one will be 4x plus 6y minus 1. And there's my answer. So I think I made a mistake here with a 9. Should have been split up into a 3 and a 3, not a 9. Any questions, come see me. If not, then have a good day.